everyone. In this video, I am going to explain single layer perceptron using the penguins dataset. In this experiment, we'll build a binary classification model step by step and evaluate its performance. First, I'm importing the required libraries such as pandas, numpy, and matplot library and performance matrices from sklearn. Then I'm reading the dataset using pandas and displaying first few rows and shape of the dataset. This helps us to understand how many rows and columns are present in the dataset. Next, I am performing pre-processing. I check for missing values using isNullOf function. If any values are missing, I replace them with the mean of the columns. This improves model accuracy and avoids error during training. And next, label encoding. Now I convert the categorical column species into numerical values. I map each species to a number and then convert it into binary classification. So finally 0, 1 class, 1 all other classes. This is required because Perceptron works only with the numerical values. And next, now I select input futures and target variables. Input futures are bill length, bill depth, flipper length, and body mass. And the output feature is species. X contains features and Y contains labels. And coming to the next, standardization. I subtract the mean and divide by standard deviation. This ensures all features are on the same scale and improves training performance. And coming to the next, train and test. Now I split the dataset into training and testing. 80% of the data is used for training and 20% is for testing. This helps to evaluate how well the model performs on unseen data. And coming to the next, I initialize the parameters. Learning rate is set to the 0.01 and its iterations is equals to 100 and weight is set to 0 and bias is also set to 0. These values will be updated during the testing. Now comes the most important step, training the perceptron. For each illustration, we calculate the net input dot product of input and weights plus bias. If the net input is greater than 0 or equal to 0, prediction is 1, otherwise it is 0. Then we'll calculate the error as the difference between the actual and the prediction. Using the error, we update weights and bias. After training, I display the final weights and each feature and the final bias. These values represents the learned model. And coming to the next, I plot the graph of iteration versus error. This shows how the error decreases during the training. If the graph goes down, it means the model is learning. And coming to the next, prediction. Now I define the prediction function. For each input, I calculate the output using weight and bias. Weight and bias. If output is greater than 0, class is 1, otherwise it is 0. And coming to the next, evaluation. Finally, I evaluate the model using different performance matrices. Confusion matrix. It shows correct and incorrect predictions. And coming to the accuracy, it tells how many predictions are correct. And coming to the precision, it tells how many predicted positives are actually correct. And coming to the recall, it tells how many actual positives are correctly identified. And coming to the FN score, it tells the balance between precision and recall. And finally, I conclude that in this experiment, we implement a single layer perspectron model and train it using a gradient updates and evaluate its performance using different matrices. Thank you.